Okay, as you can see this classification, we started from the cash flows. There are two types of cash flows: single cash flow, multiple cash flow. For single, we found present value, future value. Multiple cash flow, we have, it could be variable, like in our previous case we saw that they were different: 5,000, 8,000, 8,000, 10,000. They were not equal, so they were variable cash. Multiple cash flows, we found future value, we found present value. Then we can also have equal cash flows, so we will call it as annuity, right? So they are cash flows but they are equal, so that's why we name them different, and that is called annuity. And we will find present value of annuity, future value of annuity. So you need to write A with the present value and the future value. Okay, so annuity, if I write the annuity here, so 0, 1, 2, 3 and 4, maybe 1000, 1000, 1000 and 1000. So they are equal cash flow. Okay, so what are the different characteristics of the annuities? Number one, they are equal cash flows. Fixed amount cash flows are equal, and they happen at a regular interval. So 1000, 2000, 3000, sorry, 1, 2, 3, 4, there is no gap. For instance, if we have 0, we have 1000, but 2, 3 and 4, but here we have missing 1, right? And then we have done 1000 and then 1000. They are not there. This is not annuity. Okay, so annuity is just for this part, but for the whole time series this is not annuity. Okay, so there are no, they are regular interval, mean after every interval, after one interval there is some cash flow. Okay, for a fixed number of periods there should be number of periods fixed. Okay, so 1, 2, 3, three characteristics that you need to remember. Now we need to find the present value of annuity and the future value of annuity. Okay, so first of all, we will see a formula, but before that, if I ask you, can you find the future value of all these cash flows? Yes, we can find it. That would be 1000, 1 point maybe 6% power. How many periods? 1, 2 and 3 plus 1000 power 2 plus 1000 power 1 plus 1000. Okay, let's say if we have 50 cash flows. Okay, let's say if we have 50 equal cash flow, 1000, 1000, 1000, it would take a lot of time to calculate individual cash flow, right? So there must be a single formula, because the cash flows are equal. So why don't we have one formula? Okay, so that's why we standardize into two different formulas for the present value as well as for the future value. Instead of doing 50 calculation, future value, present value calculation, we can have one formula that can solve all these lengthy questions. Okay, so that is our first case. We want to find the present value. So no matter if we, even if we have 300 cash flows, 300 timeline cash flows, no problem, we can solve it using, but they should be equal, remember, and they should have the characteristics of annuity. So we can simply use this formula. So this is cash flow, R is interest rate, 1 minus 1 plus R. So this is a discount factor, as we know. So this is for the present value of annuity. So for the future value of annuity, same thing, because this is compound factor, so we need to use the compound factor. Here in present value we use the discount factor, so that's why we are using this as a discount factor. Okay, so formulas are same, but they are adjusted actually for multiple cash flows. Okay, so these are the future value of annuity, and that is the present value of annuity formula. So let's take an example of present value of annuity. Okay, so here is a situation. You are the lucky winner of the 30 million lottery, state lottery. You got 30 million to you got a win of 30 million. So you can take your prize money either as number one, number option A, payment 30 payments of $1 million per year. So every year 1 million, 1 million and 30 payments, or B, 15 million paid today, 15 million paid today plus 15 million in annuity form. Okay, actually I solved both the problems. So one option is that we have to take all 30 payments. So what is the present value of this annuity? The formula would be C31 million or 0.08, and all this we would substitute all the values here, and our answer would be 11,257 787. Okay, but if we use the second option, so you get 15 million today, so this is today, plus 15 million 1 million in annuity form, right? So our answer would be nearly double, more than double, right? Why is this different? So which option should you go for? Of course you will choose this option because we are getting more than this option. Why is this answer relatively lower, very low than this option? Because if you see, we have divided every 1 million how many times? 30 times. So there is heavy discounting, there is heavy discounting, while it is discounted only for 15 periods. Okay, this is discounted for extra 15 periods. Okay, so that was for present value of annuity. Okay, if you see this future value of annuity example, Ellen is 35 years old now. So this is her current situation, this is today. Okay, we are 0 at the end, and she has decided that it is time to plan seriously for her retirement at the end of each year. Until she is 65, she will save 10,000 in a retirement account. You see, each every, so it means every year 10,000 10,000, that shows actually annuity. Okay, so if the question doesn't say that at the end of the year 65, so it means that would be just one cash flow, remember. Okay, so because every each year, so that shows the annuity. She will save 10,000 in retirement account if the account earns 10% per year. How much will Ellen have saved at age 65? So 35 to 65, how many years? They are 30 years. Okay, so let's see, we need to find the future value of how much she will have when she is retiring at the age of 65. Okay, so we need to find the future value. So simply you can do a single cash flow future value also, no problem, but it will take you 30 cash flow calculation. So that's why we are going for annuity formula. So cash flow 1 10,000, 0.1 30, and our answer is this answer. She will have this much of money at the end of at the age of 65. Okay, now we can divide actually annuity into three forms, three types. Ardent annuity, when the payments are made at the end of each period. Okay, so start of the period, at the end mean here. Okay, and start of the period, at the end of the period means here. So they are made at the end of the every period. Annuity due are actually the annuity that happen at the beginning of each period, mean starting from today. So we have made some payment. Okay, so here we are making payment here. Okay, so that is called annuity due. And deferred annuity means annuity start after some period. So it means from today, after year 5, I am going to earn all these equal amounts until year 20. Okay, so for instance, I am waiting until year 5, so it means I'm not getting anything until year 5, but from year 5 onward I'm going to get some annuity 1000 for how many period? Maybe until 20 years. Okay, so that is called the deferred annuity, means the annuity happens after some time. So this is a deferred annuity part. Okay, and after this part there is no there are no cash flows. Okay, so you see we have the same timeline, 1 2 3, start of the period, end of the period, start of the period, end of the period. But if there is no cash flow in the start, it is ordinary annuity. But if it is in the start, right, it becomes due. But remember, the periods they remain same, right? So 1 2 3, there is another period, so let it be that period. I will explain how. Okay, when we will explain, I will show you why do we need this period. So these are the formulas for the annuity due, sorry, ordinary annuity. So simple formula that we just use is so far we solved some questions, and the questions they were solved for the due, sorry, ordinary. Okay, so at the end is the keyword actually here, at the end of each period, while annuity due means in the start or in the beginning of each period. Okay, so it means if you see, so sorry, if we can see it here, so this is compounded for year 1, this is compounded for year 1, okay, for another, but this cash flow is not compounded for this period. Okay, so but if you see, this cash flow has been compounded to this period, this has been compounded to this period, this has been compounded to this period, but this one is compounded for this period. Okay, this is compounded for this period. Okay, but this is not compounded until year 3, so it means we need one more compounding, so that's why we need to add 1 plus r. So one more compounding means 1 plus r. 1 by 1 plus r is discounting, but we are saying compounding, so that's why we need to do 1 plus r. So this cash flow is not compounded for the third period, so that's why we need the adjustment in the formula, whether it is present value or the future value. So one cash flow is not compounded, so we have to compound it. So simply we are going to use this formula first. Okay, so we are not going to change n or anything, so we are going to, this part is actually ordinary annuity part, so simply we are going to multiply this ordinary annuity with 1 plus r to make it due. Okay, so everything is same between ordinary and due. N would also be same, please don't get confused. At n is 3 here, we will use n3 here also, but we are going to use one extra compounding, so that's why we multiplied with 1 plus r. Because we have solved the questions for the ordinary annuity, so let's solve a question for our annuity due. Okay, and this time we are finding present value of annuity due. Okay, same example, you are the lucky winner of 30 million state lottery. You can take your prize money either as 30 payments of 1 million per year or 15 million paid today if the interest is 8%. Which option should you take? Yeah, if you see, starting from today means starting from today, so you will get the first million here. So let's see, our answer would be, so you can use the answer of ordinary annuity, and then we have to multiply it just with 1 plus 0.08, because this part remains same. Remember, PV should be equal to C divided by R, 1 minus 1 over 1 plus R power n. So this answer is for the ordinary annuity, right? N is also equal to 30 in both cases. Okay, so we are taking, this is ordinary part, but simply we are multiplying it 1 plus 1.08. So that's why this area is highlighted, just to show you that our answer would be greater than this answer, because we are multiplying it, right? So our answer is higher than the, this answer would be, our answer is this answer, it is greater than the got in previous example. Why? It is because this cash flow is not discounted back to 0, right? So this cash flow got saved from discounting, right? But if this cash flow is here, we will have discounting here. When we do discounting, answer comes less, right? So because we have one cash flow in the start, so that's why our answer will be higher. So this is not divided. Okay, when it's not divided, answer will be higher. One extra we can save, one discounting that of the cash flow that is in the start of the period. Okay, you need to keep in mind few things, that every annuity is ordinary annuity until unless it is stated, right? For instance, if it is stated in the start, in the beginning, then you have to take it as due. Otherwise, you will consider it as ordinary annuity. So that's a very important point. Okay, I'll always assume the cash flow occur at the end of the period mean ordinary annuity. Okay, but if the question states specifically in the start, in the beginning, then you have to take care of that. Okay, Now let's discuss deferred annuity. This annuity means the annuity is starting. If you see these constant cash flows, they are happening after some time. From after period 3, they are starting at the end of year 4. Okay, so they are starting from here. So that's why that is called deferred annuity. Okay, so we can solve this question. If you see there are no cash flows in year 0, 1 or 2 or even at year 3, right? So I can classify uh, this timeline into two parts. Number 1 is the annuity part, second part is actually annuity part. Okay, so this part is annuity part. So this part we don't have anything, so it means from here to onward there are no cash flows, so we cannot use this area in this calculation. Okay, so it means we have to calculate the annuity from the period it is starting. So it is starting at year 4, so it means these cash flows are included. Okay, so first cash flow is happening here, so it means we have to take 1 year less, remember, as a base year. So if I write it in terms of 0, 1, 2, I can write it 0, I can write as 3 as 1, 0, right, and 4 as 1, then 2, then 3, and then 4 cash flows, 1, 2, 3, 4, because if you see we have the cash flows here. So it means for this period I can use the present value of annuity formula, but our answer will be at year 3. So once we have this answer, then we can take it back to year 0 using the simple discounting. Simple discounting, that is single cash flow. Remember, single cash flow discounting. Okay, so this period, this is used for the discounting period. Okay, now what is the rule? Rule is, if you have given timeline from the year it is starting, the first cash flow happens at year 4, so you have to take 1 year less, mean to make it year 0, so that is 3. So 3 would be the base year, although cash flow start from here, right, but we are going to take 3 as a base year for cash flow 1. So it would be, it means our answer, the answer we will get would be at present value of annuity at year 3. Okay, so once we get this answer, then we have to take back it to year 0. So it means we have to take uh, we have to use the simple discounting. Okay, I will solve a question with you, it would be easy for you to understand. Okay, please, first of all you need to remember that we can solve this deferred annuity using ordinary as well as due pay. Okay, so we can use both ways, so I will explain how. Okay, for instance, if you see this question, what amount should you invest now if you want to receive payments of 3000? I need to use some other color. Yeah, if you 3000 at the end of each mean annuity for 10 years with the receipt of the first payment 3 years from now. Okay, okay, 3 years from now, 0, 1, 2 and 3. So first payment is happening at year 3. How many periods? For 10 years. So 1, 2, 3, 4. How many years would be? 10 years. Okay, so it means first payment would happen at year 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So if you count the number of periods here, it could be 3 would be 1, right, 4 would be 2, 5, 6, 7, and you can make a timeline. Okay, but the first payment is happening at year 3, so we have to take a 1 year less, right, so I'm making 2 as a base year. Okay, so it means this is same like another timeline. If I draw it from 0 onward, right, so 0 would be 0, that would be 1, 2, 3. So now you can imagine where would your answer be. It would be, of course, would be at year 2. Okay, so it means we have to take 1 year less. Okay, so if it is at 3 we will take 2, if it is at 4 we will take 3, right? So how many periods? 10 payments. And so that's why we are going to apply the formula of annuity, because equal cash flows for 10 periods. So present value of annuity at period 2 would be 3000 divided by R. So the present value of annuity formula, ordering annuity formula, right? And this would be our answer. So it means at year 2 this answer would be at year 2. Okay, but we want our answer at year 0 here, right? Not at here, because if you see it is 1 and 2, it is after 2 years, so we want to get it back to year PV0, right? So it would be a simple discounting, right? So that would be present value of annuity at answer at year 2 divided by 1 plus R power 2. Our answer would be 21011.52. Okay, so this is how we need to solve it. So in case if the payment is starting at year 4, we will take 3. Okay, and then we have to discount it back 1, 2 and 3. If it is starting at year 5, we will take year 4. Our answer, this answer would be at year 4. Then we have to take it back to year 0, 1, 2, 3 and 4. Okay, so remember, when you are doing the ordinary, when you are solving the question deferred annuity, you have to take 1 year less. But remember, this happens when you are considering it as ordinary annuity. So we can also solve this question using due. Okay, so remember last time how did we solve the due problem? So we have to use 1 plus R. Okay, so let's see how can we solve this. So with due, this would be the timeline. Okay, 0, 1, 2 starting from year 3. Okay, so this is true also. 3, if you see 3 here, also 3 here. Okay, so first payment, second payment, third, fourth, fifth, sixth, seventh, eighth, ninth and 10th. Okay, but we have to do 1 plus R. If you count the number of periods here, 3 is in the start, mean already it is in the start, so we don't have to take 1 year less. So the difference between solving the deferred annuity question using ordinary and due is you have to take 1 year less, but in due no need. Okay, so you will use the current year, so you will use the same period. It means our answer, present value of annuity due, would be at year where the cash flows are starting. It is starting at year 3. Okay, so present value of annuity due at year 3. Okay, so we will use the same time period and would remain same. You don't need to change anything. Okay, and would remain same, and then you have to multiply it with 1 plus R, whatever would be the answer. So you have to take it back to year 0. So how many periods now do we need to take it back? 1, 2 and 3. Previously you were taking it back to only 2 periods, 1 and 2. And if you find the answer, your answer would be the same, this answer as well as this answer. Okay, so it means we can solve the deferred annuity case. If you are confused that whether this question is asking us to solve it using ordinary or due, so it's up to you how do you want to solve it. Okay, remember, in ordinary and deferred case, you have to take 1 year less from where the cash flows are starting. If it is starting at 3, take 1 year less starting. Your answer would be at year 2, and the numbers of years would not change, remember, in both cases. Okay, and then you have to take, only difference would come here. We have to discount for 2 periods, but here we have to discount for 3 periods. Okay, so this is the important. Deferred annuity is the topic that students actually are more confused about, so they ask most question about from this deferred annuity. I hope you understood it. Okay, so from the textbook, we have an example. Jason is to start a 6 month live in training course in 4 months' time. So it means starting from 4 months. Okay, and the duration of the course is for 6 months. So first, second, third, fourth, fifth, and 6 month. Okay, his father Sam has promised him 200 per month as support payable at the start of each month. So at the start of each month, so we can think that this question could be due, but we are not worried as the answer coming from the due and ordinary are the same. Okay, if the interest rate is 12% per annum payable monthly, so 12% is the annual rate, but if we convert it into monthly, our answer would be 1%. Okay, how much money will Sam need to need today to finance Jason allowance? So we need to find the today's present value. Okay, so so let's make a timeline. 0 1 2 3 and 4. So how much he is paying? 200 200 200. So it means this period is annuity period. Okay, so first of all, this question has taken it as ordinary annuity. So when it is ordinary, we have to take 1 year, one period less, so our answer would be at here at period 3. But we are going to take how much time period? N is equal to 6. That is already taken, no need to change. Okay, so just we our answer would be at period 3. So this would be our answer. So present value of annuity at period 3. So answer would be how much? 1159.10. So remember, this answer is at P3. So once we have the answer here, now we can take it back to here to period 0. So 1 2 and 3. So for 3 we have to discount it for 3 more periods. Our answer is this one. Now we can also solve this question using due. So similarly, everything would remain same, but our first answer, annuity answer, would be at period 4, not at period 3. Okay, that was the difference. So everything would remain same except we multiply the answer with 1.01. Our answer would be at period 4. Once we have the answer here, so we have to take it back to 0, but here the period would change from 3 to 4. So we would discount one more time, 1 2 3 and 4. Okay, so if you see, our answer would be similar. Okay, so we can solve this deferred annuity case using ordinary method or due method. Okay, the next topic is perpetuity. If for instance in the annuity, just it's already given. Okay, if in the annuity cash flows are given but there is no time period or no uh, end of timeline, mean it is infinity, then it becomes perpetuity. Okay, so let's see the formula of annuity. Present value of annuity is equal to C divided by R. Okay, if I use this formula, it would be 1 minus 1 over 1 plus R power infinity. Okay, so infinity, this answer is always equal to 1. Okay, so that's why if you use infinity, this part becomes equal to 1. So the only answer left would be C divided by R. Okay, so this is the formula for perpetuity, because when it gets infinity, it is 0, right? 0, and this answer would also be equal to uh, this whole part would be equal to 1. So that's why our formula left would be C divided by R. Okay, so this is how we get actually perpetuity formula. So okay, a perpetuity is a stream of equal cash flows that occurs at a regular intervals and lasts forever. So that is forever. Here is the timeline. The first cash flow does not occur immediately, it arrives at the end of the first period, ordinary of course, right? So it arrives at the end first period. Perpetuity can also be classified as ordinary, due or deferred. Okay, so let's solve this part. So it means when we have perpetuities, so like annuity, we had classified into due, ordinary or deferred. Deferred was one of the case of annuity, right? So similarly, we can also classify perpetuity into three types: ordinary, due, or deferred, depending upon when payments commence or start. Okay, so the difference between annuity and perpetuity is that annuity ends after some fixed period of time, but perpetuity is for forever. Okay, let's solve this question, it becomes easy. So this is again the derivation of perpetuity formula. Okay, remember the formula value: cash flows one period before the first cash flow. When we will solve the question, you will understand, otherwise it would be difficult for you to understand. So that's why I'm directly moving to examples. Okay, so you want to endow an annual graduation party at your alma mater. You want the event to be memorable one, so you budget 30,000 per year forever for the party. Okay, so annual budget is, so you want that every year you want to sponsor how much? 30,000. Okay, every year, infinity. Okay, if the university earns 8% per year on its investment, and if the party is in 1 year's time, okay, how much will you need to donate to endow a party? So that's a very simple case. So PV is equal to C divided by R. So it means we must endow 3,75,000 today. Here we need to donate this much today, so that every year we have 30,000 forever. Okay. Okay, so this is deferred perpetuity. So it means this part is a perpetuity part, but this part is simple discounting part, right? Same that followed in the annuity. Okay, 8% is the interest rate. Calculate the present value of the following streams of payments: 1,000 per year forever. So 1,000 per year forever. Okay, this is the perpetuity part. With the first payment 1 year from today. First payment 1 year from today is here. Okay, from today. So it means, you remember last time when we find the when we value the annuity or perpetuity, annuity, we have to take 1 year less, right? So it means our answer should be here. So it should be simple P, not here. Okay, it should be C divided by R. We don't need to take it back to year 0, because our answer is already at year 0. Remember last time it was, if it was 4, then we have to take 3 as year 0, right? So if it is 1, then it would be at, our answer was here, right? But here our answer would already be at year 0. So it would be, C is 1000 divided by 0.08, our answer would be 12,500. Okay, so B part, 500 per year forever. So 500 per year forever. Okay, with the first payment 2 years from today. So 2 years from today mean our answer would be at year 1. So it means at year 1 we will apply the formula, that is equal to perpetuity formula, C divided by R. Remember last time we applied the annuity formula here. Now we are going to apply the, we can apply the annuity formula, but because that is infinity, so we have to apply the perpetuity formula. So our answer would be here. Once we got the answer here, we have to take it back to year 0. Okay, so how would it be solved? So our answer would be, let me solve. Okay, if you see the B part, so the 500 per year forever, 500 per year forever, with the first payment 2 years from today, 2 years from here, right? So we have to take year 1 year less. It would be, answer would be at year 1. So our answer is 6,250. So it is at year 1. So we have to take it back to year 0, right? So this would be our answer. And last is 2,420 per year forever, with the first payment 3 years from today. So that is actually 3 years for forever. So that's why we have to take 1 year less. Our answer would be at year 2, right? Once we get the answer of perpetuity at year 2, then we have to take it back to year 0. So that is how it would work, and our answer would be this answer. Okay, so these are some calculations for your perpetuity and annuity and deferred annuity, so you need to understand. So in this table, if you see the different formulas are given for multiple cash flows and perpetuity, annuity, they are all given. And next week we are going to do financial mathematics too. But for now, I am going to do a mind mapping for this topic. Okay, so you need to understand this mind mapping. So time value is to be started from the time value of money, and then we discussed interest rate, simple interest rate, compound interest rate, and in compound interest rate we discussed compounding and discounting. These adjustments, remember, we will discuss in week 3. Okay, so in compounding we had single cash flow, multiple cash flow. Discounting we had multiple cash flow, single cash flow. Okay, and for multiple cash flows we have two types of multiple cash flow: variable cash flows and equal cash flow. Okay, so we have equal cash flow, we call it as annuity, and multiple cash flow, again we have equal cash flow, we call it as annuity. So equal cash flow, then we um, this part we will explain, I will explain it later, but we followed actually equal cash flow part. Okay, so equal cash flow, when n is given, when n is not given. When n is given, it is still an annuity, but n is not given, it becomes perpetuity, right? N is given, then we discuss this part only. Okay, ordinary and due, and with growth, without growth we will discuss later, and then we discuss deferred. Similarly with perpetuity, uh, we discussed ordinary, sorry, with growth, without growth, this part will be discussed later, but we discussed deferred. Okay, so this is the timeline you will understand in week 3 fully, but for now, please remember that these are the topics we just discussed. Okay, and I hope that you have understood these topics very easily, and see you next week. I hope you would make better use of your time. Thank you so much.